Hello my dear students. In continuation of our question series from the previous year questions of target examination Neet, we will discuss some more questions from the Neet 2021 paper. So our today's question is, a particle of mass small m is projected with a velocity v equal to kve, where ve denotes the escape velocity, okay, and k is a constant which value is less than 1. Now from the surface of the earth, the maximum height above the surface reached by the particle will be, okay, we know escape velocity is the minimum velocity by which an object is projected. It will escape from the earth's atmosphere. Now according to the question, the particle is projected within velocity k times of escape velocity, okay. We have to predict the maximum height where the particle reaches, okay. By the conservation of energy concept, we can say that kinetic energy plus potential energy is equal to total energy. So the conservation of energy concept is this, okay. In place of velocity, we have put the value kve. So velocity square becomes k square ve square, okay. Now the formula for escape velocity is under root 2 gm upon r. The formula for escape velocity is 2 under root gm upon r. Now this is escape velocity square, so due to square this under root cancel out, so we get 2 gm upon r equal to minus gm upon r. Now taking common and cancel outing the similar terms, we get minus 1 upon r plus k square upon r equal to minus 5 by r, 1 by r. Solving for 1 by r, we get this value, and for r we get this value, okay. Now according to the question, we have to calculate the maximum height. So the maximum height above the surface of the earth is equal to the radius plus h, okay. Radius plus h is equal to this value. Now we have to calculate only height. So solving for h, we get k square upon 1 minus k square into r. That is our option number first, okay, because this is our earth surface, and from the center to this we take the distance as the radius, okay, and above the surface the height is actually h. We have to calculate the value of h, and both these are combined known as small r, okay. This is the required solution for this type of question from your gravitation topic. Moving to the next question. The next question is from your RLC circuit. Question says a series RLC circuit containing 5 Henry inductor, 80 microfarad capacitor and 40 ohm resistor is connected to 230 volt variable frequency AC source, okay. We are provided with an RLC circuit. The values of RLC is this 5, 80 and 40, okay. The voltage is 230 volt. Now the angular frequency of the source at which the power transferred to the circuit is half of the power at the resonance angular frequency likely to be. We have to calculate the value of which value? Angular frequency, okay. That is always measured in radian per second. We have to calculate the angular frequency at which the power transfer to the circuit is half the power at the resonance circuit, okay. We know the formula for quality factor is Q is equal to omega L upon R. So and the other formula is omega upon delta omega. Delta omega is change in frequency. Now the solving for delta omega, we get R upon L. The value of R is 50 and the value of L is 40. We get delta omega is 8 radian per second. Now resonance frequency comes out to be 1 upon root LC. Putting the value of L and C, we get omega naught as 50 radian per second, okay. Now we have to calculate the values of at half power frequency. So first is omega minimum and other is omega maximum. So omega minimum is nothing, omega naught minus delta omega upon 2, and omega maximum is omega naught plus this values, okay. So in one we have to subtract, in other we have to add the values, okay. So solving we get the required answer, okay. This is the required solution for the frequency at minimum and maximum. If we plot the graph of resonance, we get this type of values, okay. This is our resonance frequency, this is omega minimum, and this is our omega maximum. At resonance the current is current is maximum because the impedance is minimum, and at omega minimum and omega maximum current is nothing but the I naught upon root 2. That's why these are known as the half power frequency, because at omega minimum and omega maximum the power reduces to half of the maximum value. That's why we have calculated the value of these two. Now moving to the next part, the question says a particle moving in a circle of radius capital R with a uniform speed takes time t to complete one revolution. Okay, a particle is moving in a circle according to question. A particle is moving in a circle of radius, which value? Capital R, takes t time. How much time? T time to complete one revolution. Now the question says if this particle were projected with the same speed at an angle theta. Okay, firstly the particle is revolving in a circular path and it gains some velocity. Now if this particle is thrown with same velocity at an angle theta with respect to horizontal, the question says what will be the value of maximum height attained by equal to 4r. The angle of projection theta, we have to calculate the angle of projection. Okay, so firstly the formula for time period is equal to 2 pi r upon v. Now v can be written as 2 pi r upon t. Okay, we have to calculate height, so we use the formula for height of projectile motion, u square sin 2 theta square upon 2g. According to question, the particle reaches at a height equal to 4r, so we replace h by 4r. Okay, now the initial velocity is this 2 pi r upon t. This is square of initial velocity, so we done the square and put this type of value. We have to calculate for theta, so keeping aside the sin square theta and other terms on the other side, we solve for sin theta, we got this value, and we have to calculate the value of only theta. Sin theta is this, theta is equal to sin inverse this, that is our required option number first. We have related uniform circular motion with which motion? Projectile motion in this type of questions. Okay, moving to the next part, the question says two conducting circular loops of radii r1 and r2 are placed in the same plane with their centers coinciding. We are provided with two circular loops of radius r1 and r2, radii r1 and r2. Okay, r1 is bigger and r2 is smaller. Okay, now the question says the mutual inductance M between them will be directly proportional to. We have to calculate the value of mutual inductance capital M. Okay, now the formula for mutual inductance is N2 phi 2 upon I1. N2 means number of turns of second coil, phi 2 means flux of second, and I1 means current. Okay, now putting the value of phi, flux is nothing but the product of magnetic field into area. So value of phi 2 is B1 into A2 into I1. So this relation says, what relation says? Magnetic mutual induction is proportional to B1 into A2. Okay, now putting the value of B1, because it is magnetic field, the value of magnetic field is mu naught I upon 2 pi r. Putting the values of magnetic field and area as pi r square, and we get the relation between which radius. We have to show the relation between radius and mutual inductance. That comes out to be M proportional to R2 square upon R1. That is our required option number first. Okay, mutual induction comes into play when we are having two objectives, and self inductance is for single. Moving to the next part, the question says 27 drops of same size are charged to 220 volt each. We are provided with how many parts? 27 drops. Okay, same size which are charged to voltage 220 volt. Now question says they combine to form a bigger drop. 27 small are there, and say they combine to form a bigger. Calculate the potential of the bigger drop. Okay, so there is a direct relation between bigger drop and smaller drop potential. The relation is potential of bigger drop is equal to n raised to power 2 by 3. N is the number. Okay, and Vs is the potential of small. So according to the question, the potential of small is 220 and number is 27. Now solving, we get the potential of bigger is 1980 volt. That is our required option number first. This is a simple relation between potential of bigger drop and potential of smaller drop. Potential of bigger drop is equal to n raised to power 2 by 3 into Vs. Vs means potential of smaller drop. According to the question, n is 27, so we have put in the value. In this type of numerical, you will get the values that will be simply solved by this exponent term. Okay. Now moving to the next part, The question says a uniform rod of length 200 cm and mass 500 gram is balanced on a wedge placed at 40 cm mark. Okay, we are provided in a balancing system. In this is wedge which is placed at 40 cm. Okay, and the question says a mass of 2 kg is suspended from the rod at 20 cm. Okay, a mass of 2 kg is suspended at the distance of 20 cm, and another unknown mass, so we have taken a small m, is suspended at the rod at 160 cm. So m is at 160 cm as shown in figure. Find the value of m such that the rod is in equilibrium. So this type of question is directly related to a balancing concept, and in this type of numerical we just have to balance the torque. Okay, we just have to balance the torque. The formula for the torque is force into distance. Okay, by just balancing torque we get 2 gram into distance is 20, and for right portion we get 0.5 gram into 60 plus mg into 120. Solving for m we get 1 upon 12 kg. That is our required option number first. Okay, we just have to balance the torque on the LHS and RHS side, we can get the required answer. Okay, torque is nothing but the product of force into distance. Okay, yes. Moving to the next part, this is related to ray optics. A point object is placed at a distance of 60 cm from a convex lens of focal length 30 cm. We are provided with a convex lens. Okay, the object is placed at this position. How much position? 60 cm of convex lens having focal length 30. If the plane mirror were put perpendicular to the principal axis of the lens and at the distance of 40 from it. Okay, now this is our convex lens and a plane mirror is placed at a distance of 40 cm from this lens, then the final image will be formed at a distance of. Okay, this is the concept of combinations in which we have provided with the lens and there is a plane mirror. Okay, the object is at a distance of 60 cm from this convex lens and at a distance of total around 100 cm from this plane. Okay, so for the first image formation from the lens, object distance is 60. Because it is on the left hand side, we have taken minus 60. Okay, and for convex lens the focal length is positive, that's why we have put f equal to plus 30. Okay, now solving for v, we get 60 centimeter. Okay, using the lens formula we can simply get this value, v is equal to uf upon u plus f, 60 centimeter. Okay, now this is the image formed by which convex lens at a distance of how much? 60 centimeter. Now the real image formed by lens act a virtual image for the mirror. Why this happen? Because the image formed by the lens will be act as an object for mirror. Okay, the image formed by the lens is real mirror, but real image, but it will act as a virtual object for the mirror. Okay, now O1 is the object, its image is at I1. Okay, because it is at a distance of 60, so lens and mirror are at a distance of 40 and another 20 centimeter. The total distance is this 60 centimeter. Now real image from plane mirror is formed 20 centimeter in front of mirror and the 20 centimeter distance from the lens. Now for the second refraction from the lens, now we take u equal to minus 20 and focal length equal to plus 30, and we solving we get minus 60. So the final virtual image is 60 centimeter from lens or 20 centimeter behind the mirror. Okay, this is simply the application of lens formula, and the answer is option number A, that says 20 centimeter from the plane mirror, it would be a virtual image. Okay, because it is not real due to the interference of this mirror, it is in form of virtual and distance is 60 centimeter. Okay, moving to the next part, the question says a car starts from rest and accelerate. Car start from rest, that means u is equal to 0 and accelerate at 5 meter per second square. At t equal to 4 seconds, a ball is dropped out of the window by a person sitting in the car. What is the velocity and acceleration of the ball at t equal to 6 seconds? We can simply draw a diagram and understand what the question says. This is actually car. Okay, the car is running at a speed of acceleration of 5 meter per second. Okay, according to question, at t equal to how much? 4 seconds, a ball is dropped from the window by the person sitting in the car. The ball is dropped at 4 seconds. Okay, so ball is dropped in this manner. Now ball will have two types of motion, one horizontal motion and one vertical motion. So the ball is dropped at 4 seconds. That means the ball will have an initial velocity equal to the velocity of the car. So we calculate the value u equal to 0 according to question. Acceleration is 5, time is 4. So we can calculate v is equal to u plus 80 using first equation of motion. V is equal to u plus 5 into 4. We get v equal to 20. Okay, this is the required velocity of ball. Now according to the questions, Vx is 20 meter per second. This is the required x velocity. Ball will have x and also y. So Vy equal to u plus 80. Solving for this u plus 80, we get 20 meter per second, and the normal velocity v will be the resultant of Vx and Vy. We get v is equal to under root Vx square plus Vy square. Okay, so v comes out to be 20 root 2, and acceleration will be due to this gravity, that is equal to 10 meter per second square. So required answer is option number 1. Okay, we have calculated the resultant of Vx and Vy using this concept, and acceleration will be same as the acceleration due to gravity, that is equal to 10. Now moving to the next question. The last question is from your topic logic gate. The question says, for a given circuit, the input digital signal are applied to the terminal ABC. Now we are provided with 3 input A, B and C. Okay, and these are applied to the terminal. Which terminal? We are provided with the input signal applied to a terminal A, B and C. What would be the output? We have to calculate the value of output. For this type of question, firstly we have to solve the equation, then we have to put the values. Okay, so how to calculate the equation? This is nothing but AND gate, this is NAND gate, and this is OR gate. Okay, so this input is A, this input will be B, and this input will be B. Okay, so this is AND gate. The AND gate always multiply A dot B, and this is actually which gate? This is actually NAND gate. The output of NAND gate will be B dot C bar. Okay, and this is our which gate? OR gate. OR gate combines, so the resultant will be AB plus BC bar. Okay, Y equal to AB plus BC bar. Now we are provided with the values as this. Firstly, A value is, first value is 0, then up and 0. So from this type of graph, we can say this is 0. From 0 to this is 0. This is from T1 to T3 high value, T2 to T3 low, T3 to T4 high. So low means 0 and high means 1. So we just have used the concept and put the values as this. Okay, 1, 2, 3, 4 and we have put this type of values. Now after putting the values of input, we get the solution. Option number, we get the answer as y, values of y is equal to always equal to 1. 1 means option number 3. 1 means high signal. We get the answer as option number 3. Okay, this is all about the solution of your NEET 2021 question paper. In the upcoming series, we will discuss some more of the questions from your target examination JEE and NEET, so that you can enhance your practice level and achieve the target of your life. Thank you.